Okay, so in this video we are going to talk about parity bits, and a parity bit is a form of error checking within a computer system where we want to know about whether the data that we've transmitted is accurate or not. So if we take this example here, we have computer A, and computer A is going to transmit a series of binary values to computer B. It could be sent via wireless, could be sent it could be sent via like a wired communication. It could even be sent within the computer itself, from say the keyboard to the actual actual CPU. The computer is set up in what we call odd or even parity. So it is defined as if it's odd parity, it's looking for an odd number of ones, and if it's even parity, it's looking for an even number of ones. So we can see here that this particular system has been set up in even parity, because what's happened is the first 7 digits have been transmitted. So, and we start from the least significant bit, so 1 and then 2, 4, 5 zeros followed by a 1 on the end, and then this end value of 0 is the actual parity bit that we're talking about. So in this particular instance, we're being sending a binary string of data, and in fact we could even extend it out slightly to a 9th bit, and this 9th bit would still be 0 because we have an even number of ones in this particular equation. So in an even parity system, we are looking to count up the number of ones that we've got. If we have an even number, then we place a 0 in the parity bit column. Otherwise, we would place a 1 in there, because then it would allow us to have an even number of bits. So in this particular example, which we can see here as a further example, we have 3 ones in our binary string, and then our end parity bit check here would place a 1, because then that would give us 4 ones in a row, which gives us our even parity string that we are looking for. Now, issues with parity bits is that it doesn't actually necessarily catch all errors, because if you had 2 or more bits that had changed around, then the parity bit may well record incorrectly, like 2 zeros had switched, a 0 had switched around somewhere and a 1 had switched around somewhere. Nor does it tell you where the error actually is. But what it does give you is a rudimentary way of seeing whether a binary string that's been sent from computer A to computer B actually has been transmitted accurately or not. So at least it's better than nothing.